Leonard Ornstein, a cell biologist at the Mount Sinai School of Medicine in New York, and NASA climate modelers have outlined a plan to sow the deserts, the outback, and Sahara in the Journal of Climatic Change. Their conclusion is, irrigating these deserts probably provides the best near-term route to complete control of greenhouse gases. OTEC is the key to solving both the cause and effect of climate change, but the conventional approach has three main drawbacks. Cost, a perceived need of bringing large volumes of deep, cold water to the surface to condense a low boiling point vapor, and the production of power remote from where it is needed. The first two of these are related. Current designs use very large and heavy as well as costly cold and hot water pipes. Heat transfers occur at the surface, requiring the bringing of massive amounts of cold water to the platform deck to condense the working fluid. These cold water pipes are 1,000 meters long and have a diameter as great as 10 meters. Marine life entrained in such massive flows is likely to be adversely impacted, and the drop in pressure could release dissolved carbon dioxide into the atmosphere from the cold water, the same way CO2 is released by the popping of a soda cap. The weight of such massive equipment mandates that the platforms that support them must also be great and costly, and mass equates to transportation problems. Dr. Paul Curto, a former chief technologist with NASA, points out in a recent article, America Energy Policy Part 5, Ocean Thermal Energy Conversion, with a slightly different design using an ammonia heat pipe instead of a cold water pipe proposed by myself and Dominic Michaelis of the Energy Island Group. No water from the bottom is released into the upper strata of the ocean, trapping all the CO2 beneath the thermocline. Little pumping energy is used to circulate the ocean water, simply enough to pump warm surface water to flow over the evaporator end of the heat pipe. If the condensing end of the heat pipe is exposed to 1,000 feet or more of near freezing temperatures below the thermocline, no cold water pumping is required. The parasitic losses are cut in half. The costs for the cold water pipe are eliminated, along with the cold water return pipe and condenser pumps, the cleaning system for the condenser, and the overall plant efficiency approaches 85% of the Carnot versus about 70% with a cold water pipe. A further improvement to this approach will be discussed in the third installment of this series. To bring remotely generated power to shore, it can be transported by high voltage DC cable per the schematic produced by Energy Island, or ammonia and methanol have been suggested as energy carriers. Hydrogen can also be safely transported over long distances as outlined by Paul Wright in U.S. Patent Application 2010 02-69498. Hydrogen in its basic form, produced by electrolysis, is the most efficient of the energy carrier options because it involves one step rather than two or more, each with a loss of enthalpy. Not only is hydrogen an energy currency, it is also a water currency, which is an attribute that will be expanded in the next installment of this series. Electrolysis of water produces 1 molecule of oxygen for every 2 of hydrogen, and this oxygen can revitalize the growing number of dead zones in the oceans, allowing aquatic life, vital to our own, to flourish there once more. Cost is often cited as the major impediment to a clean energy future. Adaptation and mitigation are important terms in the climate change debate. Adaptation is a response that seeks to reduce the vulnerability of natural and human systems to climate change effects. The argument goes, even if emissions are stabilized quickly, climate change and its effects will last many years and adaptation will be necessary. The Canadian Centre for Climate Modeling and Analysis seems to make this point, with its finding that sea levels will rise even if we stop putting CO2 into the atmosphere immediately. This presentation, however, tries to make the argument this can be constrained in 3 ways, each with its own benefits.